Alright, this evening we're going to talk about some counting rules that we use in probability, in the study of probability, and these specifically are permutations and combinations and the difference between the two. Here are the formulas. I went ahead and wrote them down ahead of time. It's got probably some different notation than what you're used to, so I'll explain that first. This is a combination of n items selected r at a time. And in the example we're going to do, we have a group of 10, and we're going to say how many different ways can you choose 2 out of that group of 10. So a combination, the difference between the permutation and the combination is in the combination the order is not important. It doesn't matter which one you choose first. So the combination of n things selected r at a time is n factorial over n minus r factorial times r factorial. And the factorial is probably new to you as well. That's just some shorthand notation to keep you from having to write out a bunch of numbers. N factorial means, suppose it's 10 factorial, that means 10 times 9 times 8 times 7, all the way down to 1, or 2. Multiplying times 1 doesn't change anything, so you can multiply it down to 2. And so that's just a shorthand notation. You can write all those numbers out if you like, but eventually you'll appreciate not having to do that. Now the permutation, order is important. So order is not important in combination. Order is important in the permutation. And notice the only difference in the formula is the combination has the additional r factorial in the denominator, and the permutation doesn't. So which ones there are going to be more of? Given the same numbers, you're always going to have more permutations. And that's because order matters. So in a combination, if you have 2 things, it doesn't matter what order, that only counts as 1. You only count that once because the order doesn't matter. In permutations, you're going to count it twice. And I'll do an example and show you how to do that. Let's see. Suppose we have a class of 10 students and we want to select 2 reps for the student government. So that's going to be, how many different ways can we select 2 representatives from a class of 10? So we write it this way: combination of 10 things, chosen 2 at a time. Oops, that's my equal sign in the wrong direction. I make the 10 a little clearer too. Alright, I turn it around and write this out. So that's going to be 10 factorial over 10 minus 2 factorial times 2 factorial. Like that. That's the shorthand notation. And 10 factorial, I won't expand that yet. 10 minus 2, that's 8 factorial, and then a 2 factorial. Now, there's a way to reduce these kind of by hand before you resort to your calculator. You can use your calculator if you like, but you'd be surprised a factorial of a pretty small number can overwhelm your calculator pretty quickly. They get big really fast, so if you can reduce them before you put them in your calculator, you probably will have better success. Now if you're really good at dealing with all the scientific notation or whatever your calculator gives you when it gets into really huge numbers, then that's fine too. But this is just a little simple way of reducing these. Let's see, 10 factorial we said is 10 times 9 times 8 times 7 times 6, on and on and on. Well, we can bracket it, let's see, let's come back over here, equals 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2. All over. Now, what's 8 factorial? 8, we're not right there, 8 times 7 times 6 times 5 times 4 times 3 times 2 times what, an additional 2 factorial over here, which is 2 times 1, which is just 2. Now you can see 10 factorial actually also contains 8 factorial. That part of it right there is the same as 8 factorial, isn't it? So you can cancel all this, whatever it multiplies out, it's going to be equal to that. So that all cancels out. So I got 10 times 9 on the top, a 2 in the bottom. 2 goes into 10 5 times. I got 5 times 9 left. So that is equal to, what is it? What did I say? 5 times 9? 45. There are 45 different ways to choose 2 people out of 10. And when order doesn't matter. Now what if order did matter? Why would order matter? Suppose instead of just picking 2 representatives for student government, you're picking a president and a vice president out of 10. It matters, the order matters in that case because they're 2 different positions. If it was me and you being chosen, I could either be president and you could be vice president, or I could be vice president and you could be president. So order matters, you're going to have more, and that's a permutation. So let me write this one down. 10 factorial over 10 minus 2 factorial, and we've done that 10 factorial over 8 factorial, and we know that 10 times 9 times 8 factorial over 8 factorial. Let me show you the steps here. You got 10 factorial over 10 minus 2 factorial equals 10 factorial over 8 factorial, and remember 10 factorial is the same as 10 times 9 times 8 factorial. Whatever that big ugly number is divides out anyway, so we don't need to multiply it. We get 10 times 9 left, and that's 90. In this particular problem, it's kind of easy to reason it out too. We had, when order didn't matter, we had 45. Since we're picking 2 people, and like I said with the vice president president example, there's really going to be twice as many possibilities, isn't there? Because you can flip those people from president to vice president. So we have twice as many possibilities with permutations, combinations in this example. But that's because we're choosing 2. So don't expect that to hold up the whole time. We're choosing pairs for R, we're choosing 2. So that's going to work in that case, but a lot of times you're choosing 4 or 5 out of a group or however many. So stick to the formula and work it out, but this one does kind of reason out as well. And that's just a brief introduction to permutations and combinations.